Hi, everybody. Welcome to the Shiko Math Practice Lab, Learning Through Practicing. And in today's video, we will continue the limits unit. And now we are at practice set number 6. So for the past few practice set, we talk about a few special functions and show you how to find the limits for those special functions. So for example, the piecewise functions and the greatest integer functions, the absolute value functions here. Now the practice set number 6, we're going to talk about how about your function just in the general form, general type of the functions, not any specific functions. And then one of the technique can help us is by factoring. And so I'm going to show you how this techniques works here, okay? So those are the 6 problems we're going to practice at this practice set. And all of them we're going to use like a factoring or combining the terms. So right now, if you like, you can pause this video and then try to do some of the problems by yourself first and try to practice it first. Then after you finish, then you resume your video and come back to the whiteboard and we can check the answer. Okay, now, and if you want to, now is a good time to pause your video and I'm going to the whiteboard now and I will talk to you later in there. Hi, I'm back and I'm on the whiteboard. And for these ones here, I always like, do like the very brief reviews, right? And we did for the special functions, 3 different set of the video sets. We talk about the 3 different type of function. So for here, we talk about find the limits for kind of in the general, any type of the form. So how do we do that? I really don't have any specific skill. And but in here, I want to make, let's try to practice one of the technique we can use is factoring. And for the factoring, and I believe most of you know how to do that. And there's nothing really, anything very specifically to review that. So I'm not going to do the, to list out the review topics here, just, for the factoring part. Okay, so now let's take a look at the problem first. Let's work on the problem A. So this is the limit x approach to -3. And this is x squared plus 3x, right? So this is x squared minus x minus 12. When we do the limits, the first thing is you always, substitute the values of your x to the limit you try to approach to, and to see you can achieve some like the number. So now if the number exists, then your limit is there, you're done, all right? So like in here, that means that you have a -3, replace the x with your value plus 3 to the -3, and then in here you have -3 to the square minus -3 minus 12. And if you calculate this one, it turns out to be 0 over 0 here. And for the 0 over 0 is indeterminate form. So I don't know what is the value. So if in the 0 over 0, then the next things here you can take a look is, hey, maybe we can try the factoring techniques. So factoring technique is one of the techniques we're going to talk about right now. And then in the later, we have a unit called L'Hopital's rule. If you get a 0 over 0 situation, you can apply the L'Hopital's rule also, okay? So since right now we assume we don't know the derivative yet, so let's just try to work on the limits. So now in here, we say, okay, let's try to factor, see if we can cancel our trouble terms here. So I factor x out, this is x plus 3. And then this one's here, if you factor, I think this will be x minus 4 and x plus 3. Okay, now in here, as you can see, I have x plus 3, x plus 3. I can cancel. That's what is the cancel out our trouble term. Because when x approaches to -3, those two terms will become 0 over 0. That's what is give us the trouble. So now the x approach to the -3, you can just replace the x with -3. So this is -3 minus 4. So the answer here is 3 over 7 here. Right? Okay, so it's pretty easy. Okay, so now the part B is here. So this is a limit x approach to -1. And then in here, you have a 2x squared and plus 3x plus 1. Okay, so this is x squared minus 2x minus 3. You know, a lot of students, when they see the problem, they just directly go to factoring directly. But I always tell the student, when you find the limit, the first step, you just substitute the value to see you can get some, the numbers, right? So here, this will be just 2 to the -1 squared plus 3 to the -1 plus 1. Then over, this is -1 squared minus 2 to the -1 and minus 3. It turns out that this one is 0 over 0 again, right? So for the 0 over 0, then we say, okay, now how do we do this? And so one of the technique we can use is, hey, let's try to factor to see what happens here. So this one's here, I think this one you can factor to become 2x plus 1, right? I think you can factor to 2x plus 1 and x plus 2, right? I think that's it, right? X plus 2x plus 1, x plus 1, I'm sorry, x plus 1. Then this one will be x minus 3 and x plus 1. So very nicely, the x plus 1 cancel, and this is your trouble term. Then what is the answers here? So you place the -1, the plus 1, so this is -1 minus 3. So what is the answer? Is 1/4, right? Okay, so it's pretty easy. So you always check to see you'll be able to get the limits or not. Okay, let's take a look at part C. And part C, this is a limit h approach to 0, and this is h, and this is 2 plus h to the cube minus 8. You know, these problems here, you will see a lot of this kind of problem later when we start to introduce the derivative. That's what basically is the fundamental definitions about how do we define the derivatives. So that's why we kind of want to practice these problems here, so make sure we know how to do it, all right? So the first thing here still, when h equal to 0, so this will be equal to 0, right? So it will be equal to what? It's 2 plus 0 to the cube minus a to the 0. Yeah, you become 0 over 0 again. So now we say, okay, let's see if I can factor it, okay? And you can do a cube minus b cube, right? Because this is 2 plus h to the cube minus a. Or you can do is FOIL it. 2 plus h, right? 2 plus h cube. So is 2 to the cube plus 3 times 3a squared b, right? So 3 times 2 to the square times h plus 3 times 2 times h squared plus h cubed minus a. So in here to here, I use this formula, a plus b the cube is equal to the a cube plus 3a squared b plus 3ab squared plus b cubed here, right? Okay, so now let's see, and can we cancel anything? Well, yes, 2 to the third is a minus a, is cancel. And then I also notice, oh, all of them has h's here, so I can use the factoring technique. So this is h approach to 0. So here this is h, right? So I factor the h out. So what is the first one we have? 3 times 2 to the square is 12. Then plus, I factor 1h out, I have 6h here, plus h squared. Then, well, nicely, HH, this is the trouble term, it cancel out. So now h approach to 0 will be just 12 plus 6 times 0 plus 0 squared. So what is my limit for here? Limit here is 12 here. All right. Okay, now let's take a look at the next ones here. Next one is a little bit different, but still the concept is the same here, right? So this is part D here. Okay, so this is the limit. Okay, h approach to 0. Then this is h, 3 plus h, -1 minus 3, -1. As I mentioned, always check, right? So h equal to 0, so it's 3 plus 0 to the -1 minus 3 to the -1 is 0. So it's 0 over 0 again. So I know the 0 over 0, now I need to do some, the manipulation. So make sure I can cancel out the trouble term. Okay, so now let's try to do this, okay? So if you see this type of problem, first thing you flip it into a fraction. So 3 plus h to the -1 power really is what? 3 plus h over 1 over 3 plus h, this is 1 over 3. Then the next things here, what do we need to do here? We need to combine these two fractions. So I need to find the common denominator. So common denominator will be 3 plus h times 3 plus h, right? So that is my common denominator. So this is 3 plus h, so here is 3. And this is 3, so this is 3 plus h, right? Okay, so now let's take a look here. This is a limit. H approach to 0. This is h. And this is 3 plus h. So this is 3 minus h. Be careful, the negative signs, right? Okay, so 3 can cancel, right? Okay, so now you will have, this is a limit. H approach to 0. Then this is 3, the 3 plus h, negative h. And this is h. This is h over 1, right? So you flip it. So this is h, 1 over h. Ha, good. This one cancel. So now my answer will be just what? So h is equal to 0, so it's -1, 3 times 3 plus 0. So what is my answer? -1/9 here, right? So here, be careful, you need to know. So basically just try to test you to see you'll be able to combine the fractions here, right? So the similar problem, let's take a look. Problem E here. This is a limit x approach to 3. Oh, I'm sorry. So this is a 3, right? So this is x approach to 3. And then this is x minus 3. And this is 1 over x minus 1 over 3. Okay, so as always, I always like to tell the student, substitute the value in the check. So this is 3 minus 3. So this is 1, 3, 1 minus 1, 3. Oh boy, I got a 0 over 0, right? So I know I need to manipulate it and into a form, I can get the limit. So this is x approach to 3. So now let's do this combined fractions again. So what is the common denominator? 3x, right? So 3x. So this is x, so the top is 3. This is 3, the top is x. Really, it's kind of a test your algebra skills, right? So here, this is x minus 3. Then this is 3x. This is 3 minus x. Okay, so now I will kind of simplify it. So this is 3 minus x is 3x. And this one really is like x minus 3 over 1, right? So I can flip that one. So I flip it. So it's 1 over x minus 3. And the 1 over x minus 3 and 3 minus x, what is the differences? they are different by what? A negative signs, right? So if I put a negative signs here, will be x minus 3, 3x times 1 over x minus 3. Oh, wow, that's pretty good. What I have here, boom, boom, this one cancel. And now x, so what is here is negative 1 over 9, right? Sounds good. Okay, now let's take a look at our last province here. The last province here, we said is limit x approach to 16. And I have a 4 minus the square root of the x. And I have a 16x minus x squared. Okay, so now I'm going to put the value in. So this is a 4 minus square root of the 16. And this is 16 times the 16 minus 16 over to the square. Oh boy, what I have here, I have a 0 over 0. So I know I need to manipulate these ones here to hopefully the trouble term can get canceled. Okay, so let's take a look. Well, this is a 4 minus square root of x, right? So the bottom, oh, I see bottom, I can factor the x out. So this will be 16 minus x. In order to cancel the top again, so I still got a 0 over 0 and nothing I can cancel. So in here, I will do here. So 16 minus x, I can change it to the square root of x times 4 plus square root of x, right? So from here to here, what the formula I used? I used the a squared minus b squared is equal to a minus b times a plus b, right? So in here, the a, right? So the a squared, so a is 4, right? And the b is the square root of x. That's how do I get this. And after you factor this one, boom, boom, this one cancel. 4 minus x cancel, I cancel my trouble term. So the limit will just be 1 over 16, 4 plus the 16, the square roots. So this will be just 1 over 16, 4 plus 4, so it's 8, right? So it's 116 times 8. So what is the 16 times 8? It's 1 over 128. So that's how do we find the limit. Okay, that's all for the this practice set. So basically, you know, it will tell you, you know, if you get something, you can indeterminate, like for the 0 over 0, right? You always substitute first to see whether you can get a number. If it's not, then one of the technique, that's what is the technique we introduce in this set, is a factoring. And so sometimes before you factoring, you might need to do a little bit of algebra combination, like the problem, you know, like the problems like the D and the E's, right? So you need to know how to combine this a little bit, right? So you need to use the algebra to do the combination, and later you'll be able to factor that out, okay? So that's the first technique. And then in our next unit, we're going to talk about another very important technique. We use the conjugate. And that's mostly, you know, when we're dealing with the function, you know, if I have square roots type of the function, you know, how do I, you know, get rid of the trouble term and find the limits here. Okay, so that's it for this unit. And this is the one, you know, remember, if you get 0 over 0 or some indeterminate form, maybe you can try. So one of the techniques we always try to do first is you try to factor that, right? So if you can factor out the trouble term, then you can find your limit. Okay, that's it. So remember what you need to do? Practicing, practicing, and practicing, right? It will make you getting better in math. Okay, so if you like this video, feel free to subscribe it. Or, you know, if you have questions, feel free to leave me a comment and I will try to respond to your comment. Okay, and so nice to talk to you again, and looking forward to talk to you in my next video. And how do I get a limit by using the conjugate techniques here. That's it, and you have a nice day. Okay, bye.